Good morning everyone. So in the last class what we have done? We have learned the different important missions by different global agencies like NASA, ESA and all other agencies. So in this class what we are going to do is basically focus on different astronomical observations that has happened in the recent past. India has started so many new observatories. So all these details will be discussed in this class. Let's get started. So before starting the class, the picture is not that much clear. Let's have a fair idea on what are different kinds of frequencies, what are different kinds of electromagnetic spectrum that is available and what we are trying to do. So this is what this region is called. It is having radio waves, microwaves, infrared. This region is called what? Long wavelength region. Long wavelength means frequency will be, what is wavelength? This distance between the one XYZ point in one wave to the same corresponding point in the other next wave, it is this distance is called wavelength. And what is frequency? How many times this ripples happens in 1 second? That is frequency. Unit of frequency is hertz. So longer the wavelength, less number of times it will happen. So longer wavelength means frequency will be less. So these are like radio waves, microwaves, infrared. Comparing to visible lights, these are long wavelength and low frequency waves. Now what is energy content of XYZ waves? Energy equation general equation is H nu. H is Planck's constant, so it will be a constant. Nu is what it is? Frequency. If it is frequency, high frequency means it will carry more energy. More increasing frequency means it will have more energy. So these radio waves and these extremely low frequency waves, these will be least energy waves. So this will be used for like subways, electrical system, AC power, these kind of applications. It will be used like this long wavelength waves it will be used. After that, next higher frequency waves is radio waves, radio spectrum. These have all the broadband communication applications we are using. Communication applications, mobile phones, wireless, RFID, all these are used in this radio waves region it will come. After this come microwaves. Microwaves also we use for satellite communication. We also use for some other microwave communication, microwave antennas and all. Then come infrared. Infrared, what is the purpose? These are like heating waves. Sun's infrared waves we are absorbing and we get heated up. So that is the main objective of, there is just beyond frequency of visible light. After this there is a small band of light that is called visible light. What is the frequency range? Around 300 to 700 nanometer, that is the range of visible light wavelength. After visible light, then higher energy waves are UV rays. It's a more energy, that's why it will create burning, it will create skin cancer, all these alterations. All these wavelengths, this is above this, then can create health XYZ issues. Any waves beyond this is not going to create that much of a health issues. Why? They are mostly called non-ionizing waves. Non-ionizing waves means even if they hit on your body, your molecular structure, it cannot alter. It cannot make your molecules ions. If a wave is making your molecules ions, that means the molecule is disintegrated, that molecule is dead. So and those waves which have energy level beyond this visible light, they are called ionizing waves. They are creating XYZ issues or health issues. If there is over exposure to it, that can have health issues. Here there is ultraviolet waves. These are coming from the sun. Where it is absorbed? In the ozone layer. Ozone layer is in which layer of atmosphere? Ozone layer. It is mostly in stratosphere. So X-rays, gamma rays are what are gamma rays? We will see this in future. These are the highest energy electromagnetic energy levels which are feasible. Gamma rays, starting from very low frequency waves to gamma rays, you have this whole spectrum is electromagnetic spectrum we will see, and everything has very different applications. X-ray, you know, will have medical applications, radioactive applications of gamma rays, like you have whether there is XYZ material is there, you study the radioactive phenomena of that place and identify it if uranium is there. Carbon dating, all these are done by using this gamma ray phenomena, whereas everything has different applications. Now when it comes to astronomical observation, what is the XYZ purpose? We have different telescopes, different antennas, different space telescope. Every telescope will have different frequencies to look for. It is not like one telescope or one equipment can look all these ranges. Everything need different kind of equipments. So every satellites you will see will come study different ranges of this kind of different ranges of waves that is coming across. General properties, by moving here, wavelength got reduced, frequency get increased, energy level of the waves get increased, and after crossing this visible after this range, ionizing waves will start to form. Go ahead. Now if you have an obstacle, these waves can pass through any obstacle. There will be no XYZ interference. While with more high energy waves, it can get interfere with the obstacle and cannot penetrate to different objects. Go ahead. So these are like a general overview on different kinds of telescopes. Gamma ray telescopes. You will not see that much of gamma ray telescope. What it will study, we told gamma rays are most powerful rays in the electromagnetic spectrum. These are only gamma rays telescope is study only gamma rays that is coming from the outer atmosphere, and gamma rays is most powerful. It is not coming every time. Only rarely you will get gamma burst for 2 seconds or more than 2 seconds. You will get some gamma burst. Only at that time you will get exposure to these gamma rays. So these kind of telescopes, when these gamma rays are produced, under normal situation gamma rays are not produced. It is produced on special events like supernova. We will discuss all this in the later slides. Supernova, neutron stars will have slides for this. Pulsars, black holes, all these phenomena, something is happening, then only this gamma rays are being generated. These are some example gamma ray satellites for this. You can look at it. They are not that much recent, so that much importance is not there to exactly learn the name. But you should have an idea that this is a spectrum and this is the range it is looking at. X-ray telescopes, X-ray space telescopes are there. It will specifically look at, these are like little lower energy levels. X-rays, you can still get more number of X-ray from the universe. Gamma rays are very rare. This is, you can get still more number of it. So it will supernova, remnant stars, binary stars, dwarf stars, all these neutron stars, black holes, everything of this will emit X-rays. So you can study all these in different examples are there. IXP is the most recent one that is launched by NASA. IXP, that is a X-ray telescope launched by NASA in 2021. That's the most recent one. Then we have UV telescopes. UV telescope means it will be looking at the ultraviolet region. Even our sun is emitting this. These radiations you cannot see from the sun directly, but this UV rays, from UV rays, all other radiations are coming from the sun, stars, galaxies and all. Examples are like SHIELD mission of NASA, or SHIELD telescope of spectrometer of NASA is the most recent example. AstroSat, you can see it is looking at low UV rays. AstroSat, you can see here also, it is looking at visible light also. AstroSat comes in different sections. Why? Because AstroSat is a multi-band observatory. It can look at different wavelengths, different payloads are there in the AstroSat. That's an Indian mission. Go ahead. James Webb we have in infrared region now. Yes, it is there. Visible light, we told that 300 to 700 nanometer, in that range if frequencies are coming. Especially telescope launch for that purpose is visible range. Recent one is CHEOPS, CHEOPS, launched by European Space Agency is the most recent visible range telescope that is being launched. Infrared and sub-millimeter range, there is also CHIPOS, and James Webb telescope, that is specialized telescope, most recent. We had already had a detailed discussion on this. This is basically a infrared telescopes. Microwave telescope means much lower energy. Radio space telescope means radio telescopes mostly you can see in where? In Earth itself. Why? These are like very low energy, so least interference by this atmosphere and other pollutants here. It can mostly pass through many of these objectives. Less scattering happens. So due to this, radio telescope mostly it is not like it cannot be placed there, but most radio telescope you will see in the Earth, installed on the Earth itself. While these all are mostly, it is best if it is installed in space or other programs. So this is a broad picture. Go ahead. Gamma outbursts. This was I am saying, like normal events you cannot get gamma rays from any stars and all. It is not feasible to produce this much intensity light from normal stars, sun and all. It only happen very special events, something like this happen. What is the special events? We discussed about it, like supernova. What is supernova? Tell me. We have a slide for that. We don't have. What is supernova? When there is two stars coming and colliding, if they are merging into one star, such an event happened, then it is said that around 30 times the total energy of the stars of our sun will be released in few seconds. Getting? If two stars come, hit and collide, then you will get something of intensity, some cosmical event of that much intensity happens. Then only you will get what? This gamma outburst. Gamma outburst usually happens for a very small seconds, like 2 seconds or so. But in this 2 seconds, hold the lifetime of how much energy is released from the time, 30 times the lifetime energy released from the time sun will be, in the lifetime of sun will be released in this 2 seconds. So you can imagine how intense that event is. And if something like this happen, it will interfere with all the nearby areas. So this kind of events only generates this gamma rays. And we have not observed so much of many of these gamma events. We have observed only very few number of gamma outburst events. Or some black hole, if a black hole capture a star, that kind of events can also lead to gamma outburst events. Go ahead. What is life cycle of a star? This is also some basics you should know. All stars are produced from some kind of gas called a stellar nebula. This will be a scattered gaseous structure. From this scattered gaseous structure, some combining or some coming together happens of some XYZ materials and stars are being produced. It is that during this phase what happens? This is the first there is protostar stage. That is this nebula. You will see everything as nebula. After that, when star is produced, this is called main sequence stage. What is specialty of main sequence stage? This is the stable life cycle of a star. Like sun, you are saying every day it is there and it is constantly producing energy. Constantly it will be producing energy. This is main sequence stage of star. Now after the energy of a star is going to finish, then what will happen? Then it will turn into red giant or red supergiant. Why it is turning red? Because the energy it was previously emitting, that much it cannot emit. So two things happen. Now intensity of energy emission reduces, then it started expanding also. Previously it is only this much, it started expanding. That is formation of these two different path cycles are only based on size of the stars, mass of the stars. Rest the process happening is very much similar. So red giant stage means when the fuel of a star is going to finish, it will turn itself into a red giant. Red giant means energy emission will reduce and it started expanding itself. Next stage is planetary nebula stage. What will happen in this stage? Supernova is this kind of event. What happened in this stage? Supernova is not collision. Supernova is one star collapses into itself. This whole energy system of this star will collapse into itself. This kind of event happens if it is a massive, very big star, and this will lead to formation of either a neutron star. Where it went? Okay. If a very big star is the red giant, then it will collapse into itself. That phase is called supernova. Then it will lead to either production of a black hole or production of a neutron star. Neutron star means it will be basically made of neutrons and high electronic particles. High ion particles will be there. So, this will happen only if the size of the star is more than some number is there, 1.3 or 1.4, the size of our sun. If star size is bigger than this cycle it will take. Otherwise, it will lead to red giant will be there, then it disintegrate more and it will lead to planetary nebula. There will be no supernova phase, there will be no black hole, it will form to black white dwarf. That means a low intensity star it will become. Low intensity, low mass stars it will end up into it. Where our sun will go which path? Our sun will only go this path. This can only be gone by very huge stars which is much greater than the mass of our sun. Go ahead, rest you can read about it here. You can pause the video and you can go through it. Now black hole anatomy. Why we are studying this? Because there has been PYQs on exact anatomy of these black holes. What is black hole? Black holes are those regions in the space where gravity is too high that even if light enter into the system, light cannot come above this gravitational pull. Such a region is called black holes. Now the best explanation given by this space-time fabric of this Albert Einstein concept. What this space-time fabric says? Everything that has mass will create a ripple or will create a fall or dip in the space-time fabric. If sun is having huge mass, so it will be creating this much of a ripple or this much of a dip in the space-time fabric. Neutron star is having much more mass, considerably huge mass. So it will create much greater gravitational pull or much greater dip in the space-time fabric. Now if you look at a black hole that is having the highest dip in the space-time fabric, so if a light enters this system, that is where we call it as, if light enters this system, then it cannot even escape from this system. And this system at this point is called event horizon. Not light, any XYZ thing, if it reaches the event horizon, entered it, then it will cannot even escape from the gravity of this black hole. It is having supermassive gravity. Other important point is singularity. What is singularity? The state of affairs, state of matter at the innermost point of the black hole. That is still not conclusively known what exactly it will look like. That point is called singularity, event horizon. Then there is acceleration disk. That is the small region beyond this black hole is called acceleration disk. There you can see photons rotating around a black hole. If a photon or any other subatomic particle is not going into horizontal event horizon, then it will not be captured by this black hole. Some XYZ photon is at this range, it can go in this rotating around a black hole phenomenon like planets rotating. Okay, go ahead. Next we have this dark energy, dark matter concept. This also we discuss, I think too much times in the class. What is dark energy and dark matter? If we look at the universe, whole matter what we see, including sun, planets, moon, asteroids, everything combined, it is only constituting less than 5%, 4.9% of the total mass of the universe. Around 68% of the total mass of the universe is dark energy, and around 26% of XYZ universe is dark matter. Now what exactly dark matter is? We doesn't know, we haven't direct observation of this dark matter or dark energy, but we have evidences that some kind of some system like dark energy and dark matter should exist. And what are these evidences? First, it is we are assuming that there is a Big Bang. This all come from this Big Bang concept. When Big Bang happened? Around 15 billion years ago. Now when 15 billion years ago Big Bang happened, what happened to the universe? Universe started expanding. Now if you look at this expansion over the time, the rate of expansion should slowly reduce. That is normally what you expect. There has been a huge high intensity explosion. Then over the time, the rate at which these galaxies are going apart should come slow down, or it will come reduce. But when you do the observation, you see that till a point it was going like this only. The acceleration of the galaxies were coming down. But after this point, what happened? The galaxies started going at a much higher pace. Now, if galaxies are going at a much higher pace, what exactly is pulling these galaxies? What energy is these galaxies are being impacted with? So that after a phase, it started going apart at a much accelerated phase. So this why is substantiated by there should be some other component in the universe that is called dark energy, that is so huge that they can pull the whole galaxies apart, or push the galaxies at a much higher pace than it normally goes. This leads to the conceptualization of dark energy. Yeah, we're coming into it. Now next part is dark matter. What is dark matter? Two observations are mainly made for this. One thing is we know different stars. We see what is the stars which is staying here, and if we calculate what should be the gravitational field that is exactly acting at a point, and every point we look at, we get a considerably 30%, 40% higher gravitational field. Where this gravitational field is coming from, we exactly doesn't know. So there should be more mass in the universe than that is currently there. Then only the universe can stay in this stable state we are seeing right now. So there should be more mass. Other thing is gravitational lensing. What is gravitational lensing? Some source of light is there, like X-ray, gamma ray, or some ray. Then it is coming. There is a galaxy here. This galaxy will be too huge. You are expecting that this light will get absorbed here, and Earth is here, and we are observing from here. So we are not supposed to see this light coming from these XYZ galaxies. But interestingly, what we are seeing is the light go bending and reaches our eyes. So the gravity of this XYZ universe or XYZ galaxy is capable at many places to bend the light. This exact phenomenon is called gravitational lensing. Now, if gravitational lensing is happening, we will see the X source here. Gravitational lensing we are observing at more places, we doesn't know what is in between. So we are observing gravitational lensing, as well as there is more amount of gravity required to keep this universe as stable as today it is. So there should be some XYZ dark matter which we haven't discussed. What should be the exact property of one peculiar property of this dark matter and dark energy? We have discussed about a huge range of electromagnetic spectrum. If dark matter or dark energy interacts with any of these waves, from gamma rays to very low frequency waves, if it interacts with any of these waves, we would have observed it. If it reflects some waves, if it emits some waves, we would have easily observed it. Some kind of our telescope would have observed it. But this dark energy, dark matter is having no interference with all this electromagnetic spectrum. So that's why it has become absolutely difficult or nearly impossible to observe this dark matter, dark energy. Now some statement questions. Dark matter doesn't mean it is dark. Dark matter simply means it doesn't interact with electromagnetic spectrum. Dark matter is not clouds of normal matter. Dark clouds of normal matter ऐसा कुछ नहीं है dark matter. It is completely total another kind of a XYZ material. Dark matter is not antimatter. Antimatter is associated with subatomic particles, quark, and all these. Dark matter is not associated with antimatter particles. Dark matter is completely XYZ another matter. Dark matters are not black holes. Black holes are totally different concept. Black holes are happens at the end of life stage of a stars, and these are areas where stars collapse into itself and there is huge gravity. This is totally different concept. These are not black holes. These are different concepts in itself. Go ahead, if any of this statement is there in your exam, you should be easily able to identify this is wrong statement. Go ahead. Now what is blue stragglers? Blue stragglers are interesting for one reason. We were observing, we have so many telescopes, we have huge electromagnetic spectrum provided to us. So we have been observing different galaxies. Now when we are observing one old galaxy or a set of old galaxies, what is the old galaxy phenomena what we are expecting? We have told that stars at the end of their lifetime, what happened? Stars transform into red giants. So red is the color that comes when energy is less or a star is going to end its life. When it is moving to that phase, we are only expecting red stars or red color we are only expecting. And blue is the opposite color. Blue we are expecting when a star is at its full energy state. It is emitting so much of light, at that phase we are expecting blue color. Now here we are observing some old galaxies or old stars. And in this mix we are only expecting red stars because all these stars has reached the end of life cycle. Now we were observing 1 star, 2 star, 3 star. Then surprisingly we are seeing a family of blue stars sitting in between this, in the midst of red star. Now where did this blue come from? That becomes very interesting. We are observing old stars. Old stars can only be red in color. Now we are expecting all red color and most of the stars are red itself. Every our theory is very good. But in between there are 1 or 2 blue stars also. These are called blue stragglers. Now where did they come from? How did they reach there? A totally new life star in between so many old stars. The answer is 2 old stars may come together, they might have combined. And when they combine, there may be so many release of energy that will be acting as new star. There may not be actually a new star, but 2 old stars come together and combine together to form a new star that is actually having much more energy than all other stars. Since it has much more energy, we are seeing it as a blue star. And these XYZ stars are called blue stragglers. Rest you can read from here. It will having slightly greater mass than the other stars which you are observing in the XYZ plane. Go ahead. Now next we have tidal disruption events. Why this is interesting is, if some option is there in the paper, what is tidal disruption event, and you have x1, 2, 3 option. It is very tendency is to go and pick something associated with high tides and low tides. But tidal disruption events is totally a cosmic event. It has nothing XYZ to give with high tide or low tide. What is tidal disruption event? We speak about black hole. Black hole means it will pull everything into itself, huge gravity. But all this pulling will happen only if XYZ enters event horizon. Now if a star doesn't enter event horizon, it just passes through an black hole. Then what will happen? The black hole is so powerful that it will tear the star into multiple pieces. If star is not entering the black event horizon, if you enter event horizon, black hole will eat the star. But if a star just pass through the other influencer region of the black hole, it becomes so powerful that the star becomes teared up into different parts. One star will be like teared, and after it will not contact, it will pass through the influential area of the black hole. Black hole is so powerful that the one star will be like thrown into different directions. Sun's form, whatever the star, it is the same form. Material change kuch nahi hoga. But star's properties will completely change because mass is completely less in these systems. Tearing the star, it is happening. due to this power of this black hole. These kind of events are called tidal disruption events. Acceleration disk of this black hole, if a stars come into the acceleration disk of this black hole, this tidal disruption event happens. Go ahead. Andromeda Galaxy. What is it? It is nearest large neighbor galaxy to the Milky Way. Milky Way is our galaxy. What is speciality of this galaxy? There is 4 billion years is the gap between these two galaxies. What is life of Earth? Around 4.6 billion years. And now these galaxies are itself 4 billion light years apart. So light from this galaxy, what we are seeing means the event might have happened at the formation of Earth phase. That light we are observing today from these galaxies. What is another speciality of this galaxy? This galaxy can exhibit something like cosmic cannibalism. What is cannibalism means? Cannibalism means eating same species. Now cosmic cannibalism means this galaxy can come and eat the Milky Way and itself become a very huge galaxy. So this kind of XYZ can happen with associated with Andromeda Galaxy. You don't have to fear something like that because it is currently 4 billion light years away. So it will take huge time even if something like this happens, but it has the capabilities to exhibit this. Now the structure that is formed after cannibalism of another galaxy, that is called Dulles structure. It's more of very factual things. At least remember you seeing this galaxy, this is the exact characteristics of this galaxy. Have this mental connection. Go ahead. Indian Astronomical Observatory, where it is? Hanle in Ladakh. It is around 4,500 meters above the mean sea level. At the top of Mount Saraswati, Nilamkul plain in the valley of Chatang, Ladakh. Changtang. Okay. Why we are keeping this observatory, astronomical observatory in Ladakh? Yeah, it is at this much height. That means it is free from atmospheric pollution, all these kind of things. Secondly, this atmosphere is also, this region is something like a dry desert. Dry desert means less cloud, also less water vapor in the atmosphere. Water vapor is something huge absorbent of XYZ waves. So water vapor will not be there, atmospheric density will be very less because you are at this much height. Due to all these factors, this is very good position for doing the astronomical observatory. That's why you will see more other also, there is something other also coming. More telescopes, more observatories are being installed at Ladakh region. Go ahead, rest about this. What kind of telescopes are there? You can read from here. Himalayan Chandra telescope is there, Growth India telescope, high altitude gamma ray telescope. All these are installed in this Ladakh region. Go ahead. Dark sky reserve, what it is? Dark sky is more associated with minimize the light pollution. Already told Ladakh is a very good region for space observation. If you are doing space observation, what you really need is minimize the light pollution. So with this objective, India declared Ladakh region as India's dark sky reserve. Objective is to facilitate this XYZ space observation of this Hanle observatory. Go ahead. Giant microwave radio telescope. Where is it? GMRT. It is located near Pune. Pune is in Maharashtra. It contains 30 antennas of 45-meter diameter. It will observe which range? Meter wave radio waves. It will also look into pulsars, galaxies, early universe. It was inaugurated in 2002. It was operated by National Center for Radio Astrophysics, which is a part of TAFR. This is the frequency ranges which this XYZ observatory is looking at. 150 megahertz to 1.5 gigahertz frequency ranges. Now, why this is in news? Because it discovered something like fossil radio galaxies. What does that mean? Fossil means what? Something that has died, and something that is not existing is ka remains of something that is died. That is called fossil. So it has discovered some radiations from a galaxy that is currently not there. That galaxy has completely died out, or that stars has completely died out, but the radiations has been coming from years after the death also. So this XYZ observatory observed something of a fossil radio galaxy from 260 million years ago. Go ahead. Liquid mirror telescope. This is, you can just look at the concept a little bit. Where it is installed? It is installed in Devastal region in Uttarakhand. This is world's first liquid mirror telescope that is completely for astronomical observation. So far all this telescope for military observation or something like that. So what is speciality of this? This is installed at Devastal in Uttarakhand. It will be operated by Aryabhatta Institute of Observational Sciences. What is speciality of liquid mirror? Functioning is, here there will be a huge mirror. What a mirror does in this kind of a system? There should be a convex mirror, something like this. Then light falling on this will be focused on this. Liquid mirror means you keep the liquid on this, then you rotate this surface. This surface will be rotating at very high speed. Now, very high speed means it will give a, due to the centripetal or centrifugal force, the liquid that is present here will take this form. Now, this liquid will be, what kind of liquid will be used? Mercury. Mercury is used, it can reflect all the light falling on this. Now, it will reflect the light, and here there will be sensors and use that for observation. This kind of telescope is called liquid mirror telescope. It has considerably higher sensitivity, that's why we are using it. Go ahead. Rest you can read out from this here. You can pause the video and read out the details. This is interesting. Digantara. What is it? We have already told that space sector, what is the biggest trend that is happening? In coming of private sector. We have seen that one full rocket was launched by private sector. What is the name of the rocket? Vikram S rocket. That was totally launched by private sector company. Now this is Digantara. Digantara is what? Uttarakhand to have India's first observatory to monitor space activity. Why this is important? What is importance of this? Chinese satellites, some Chinese satellites are observing Indian XYZ. So you need to have, at least have which satellite is observing India. So to get to that all data and information, we have Digantara, this space observatory will function. This will look at the other space activity that is happening over the Indian space. It is a space sector startup, India's first commercial space situation awareness observatory. It is also to be installed in Garhwal region of Uttarakhand. 10 cm in size material can be observed using this. We have seen this 10 cm in other case also, where it was Netra project of ISRO. What it was? Very similar project. This is for space debris. Here the objective is not space debris. Here the objective is looking at the space activity around the Indian space. Go ahead. Name is Digantara. This is the simple and details. Now we have SARAS 3 telescope. What is SARAS 3 telescope? Throws light on the nature of early stars and galaxies. Mainly it is built at Raman Research Institute. The Dingle Lakes are backward. These are in which state? Satellite is at Karnataka. Why is it in use? It has given some observation regarding phase called cosmic dawn. What is cosmic dawn? if you look at the Big Bang, if you look, the explosion happened, then this cloud will be, nebula cloud will be formed. Till a huge phase, there was no formation of stars. Only after this phase, then stars started forming. So this phase is called dark phase, or dark phase after Big Bang. Now cosmic dawn means at the end of this dark phase, this phase is called cosmic dawn. $550 million to 1 billion years after the Big Bang. That is exactly the time for cosmic dawn XYZ. Go ahead. Square Kilometre Array Observatory Telescope, SKAO. This is world's biggest radio telescope. Where it is being installed? Two countries it is being installed. Where it is? One is in South Africa, other one is in Australia. South Africa, where it is? Karoo Desert. In South Africa, it is in Murchison Radio Observatory. Karoo Desert, KROO. Rest details you can go through it. 3 countries are majorly part of it. Its headquarters is located in UK. Then obviously South Africa and Australia are part of this. It is going to be world's biggest radio telescopes. It's still being built. It is not completely functional right now. Different frequencies it will look at. You can go through the details. Go ahead. These are all very factual data. Now this is 30-meter telescope, TMT. What is specialty of it? 30 meter means what will be 30 meter? Diameter of the telescope will be 30 meter in size. 30 meters, such a huge dimension we will have. It will be looking at ultraviolet and infrared wavelengths. It can give a sensitivity of more than 80 times of the current satellites. Now where it is being installed? Where it is being installed? It is being installed in Mauna Kea on Hawaii Islands. Where is Hawaii Islands? Which ocean? It is somewhere in the mid-Pacific, somewhere here. Here will be Hawaii region. So this is the location for Mauna Kea on the Hawaii Island. This is the location for building this TMT telescope. But one alternate location is also found out, that is on Canary Islands. Where is Canary Islands? That is Atlantic Ocean near this Africa. There is Canary Islands. These are 2 locations for 30-meter telescope. Primary location is in Hawaii Islands, Mauna Kea only. And it is coordinated by University of California. India, Japan and China are the 3 other countries which are part of this program. TMT telescope. Go ahead. Strong thermal telescope velocity enhancement. Steve, what is 2 things which you need to know? These names look like something very big. What exactly is this? We have seen aurora. What is aurora? This solar flare come and interact with the ionosphere ions, then light will be produced. This will be only observed at very high altitudes or latitudes near the polar regions, Scandinavian countries and all. This is similar, very similar observation that is done in at lesser altitude regions, later latitude regions. And aurora means whole sky will be colored. Here whole sky is not colored, but a stream of colors, blue stream or purple stream of light will be passing through it. And what exactly is this? These are called rivers of ions that is passing in this ionosphere. These ions will be moving too fast, they are colliding with itself, and that will result in formation of this kind of green line. Since it is something like rivers of ions, it doesn't mean solar XYZ. So that's why it may be observed in not at equator regions, but at slightly lesser latitude region than the auroras. Rest everything look like same as auroras, but it will be like a stream of light. Name you have to keep in mind: strong thermal telescope velocity enhancement. Steve. Atmospheric glow similar to aurora, which can be triggered when a stream of solar plasma interacts with the atmosphere and magnetosphere. Go ahead. Okay, so that is end of astronomical observation part. We covered so much developments that is happening in India as well as all the major developments that is happening in the different parts of the world. Starting in the lecture, we have covered different kind of spectrum and what is the different applications of it. Steve, what it is? Aurora, what happens? Solar flare will come and this flare will completely scatter around the earth, interacts with ionosphere. This ion-ion collision will lead to colorful sky and the whole sky will be glittered with colors in Scandinavian countries and all. Now aurora happened due to some plasma that has come at some point of time. This plasma will be collected at some region and due to some force this plasma started flowing like a rivers. The river of plasma is happening in the ionosphere of the atmosphere. And this river of plasma will lead to a similar color like aurora, but it will be like strip of colors. It will be green, there will be another strip like this. So not the whole sky, strip of colors will be formed. Another peculiarity, it is not in the, aurora is only observed in the highest latitude, polar region, Scandinavian region. This is observed at slightly lesser latitude regions also. Why this is so much important is the name is given, ABCD is there, only you can answer if you know it. Otherwise, you cannot go with the what is the full form of this, you cannot connect with this. SARAS 3 telescope, yeah. Digantara. Digantara is it's a space, private space observatory. First India space observatory. We speak about Netra. What was Netra doing? Debris it was observing 10 meters and 10 centimeters size. It was a project of ISRO. This is a private observatory. This is installed at Garhwal region of Uttarakhand. Speciality is it is to observe the space activity that is happening over Indian space. Especially it's a strategic project. Some other countries observing Indian XYZ regions. Then that at least this country is observing that information India has to have. So space activity around Indian space you have to get for that. This private sector, private startup is the Digantara. Okay. So that's all, we comprehensively covered this. So most XYZ data on the space sector we have covered with this 5 series. If there is anything pending, we will take a miscellaneous class on this. But major all the aspects, major all concepts and most of the recent developments we have covered with this. That's all for now. Thank you.